Welcome to the machine learning at home. Today will be one of the most simple of my videos because I will use like only two commands. So my goal is to show how to choose the best clustering method. Because again, like in many fields of machine learning, there are so many different methods. Then the people kind of lost when they see all these explanations, formulas, and different algorithms of these methods. So to me, one of the best approaches in that case is kind of, well, run and see approach. So take your data or maybe some other data, look on results and decide which method is better for you. One of my approaches is to use some comparisons, and this already was explained in one of my videos. And next interesting approach is to use some artificial data. That artificial data may be of different kinds, and then you will see how different clustering strategies are working with artificial data, and that will influence your decision of which methods are better. So let us run it. Let us run my package first. Again, if you don't have it installed, you first install it with the command install.packages, and name of package should be in quotes. But hopefully you already have it installed, so let us simply load it. Okay, and now I will run just one simple command. Example of generation of clustering data. The command is gen.cl.data, just to allow you to type less. And so in Unix, typically I'm working under Linux, you will need to type return multiple times. If you work on Windows, you will click on your plot. But it's okay, whatever method is working, it's always the same. So let me show you some examples how this artificial data approach is working. So these are one of artificial data. So these are three different clusters, very well separated, anisomorphic clusters. Now another kind of artificial data and many other methods available in that command as well. So look here. So there are two noisy circles, two noisy moons, artificial data, data without structure. It's quite useful to see how different clustering methods will approach the situation where there's actually no structure in data, three blobs, three anisomorphic clusters, and one of varied. One cluster is very dispersed, one cluster is very dense, and a third cluster is outstanding. So a very big diversity of artificial data, and we can now see what's going on. So this is a slow plot because it will run multiple outside packages. So for example, in your case, you might need to install some additional packages. So this is word methods, UPGMA methods of typical clustering. Inside are k-means, Diana and Fanny of cluster package, spectral clustering, affinity propagation, dbScan, mean shift, and mclust. So you probably will need to install some of those packages. So for example, affinity propagation, dbScan, mean shift, and mclust are all different packages. If you see some warnings or errors in output, you might approach it and install packages which you will need and then run this command again. Then it will be perfect. In my case, all packages are already installed, and it will work with all types of data. So with two noisy circles, two noisy moons, no structured data, and so on. Okay, I like now to see what is going on. So this is a two clustering methods. they're not very successful in understanding circles or moons. They split it in a non-logical part. They also found non-existing clusters in no structured data, also not good. But they are very, very good in a way of when you need to go with typical clusters. Word method, for example, is also very good with the last case, when one cluster is dense and one is spread and they are overlapping. It's a rare situation. Only mclust is good in that from other methods. Also funny, also not too bad. Anyway, so this is UPGMA is also good, but last case is not so successful. K-means, well, unfortunately doesn't work very well with most of cases in this artificial data. Diana clustering is not so bad, typical, similar to UPGMA. So Fanny, so fuzzy clusterization, you see some dots are transparent, means that clustering algorithm doesn't place them in any of three clusters. It's interesting approach, and it works quite well and also works with the last example. But still unable to do anything with circles or moons. Spectral clustering is famous exactly because it can approach these embedded moons or circles quite well. But unfortunately it still finds some structure in case where no structure exists. So also works not too bad with next examples, but doesn't disintegrate the last example, doesn't distinguish dense cluster from spread cluster in a most low group. Affinity propagation is very good in understanding moons and circles, so similar to spectral in many other ways. DBSCAN is good about moons but not good about circles. It also the only one, actually one of two, which understands that no structure has no structure. That's important. So in case of you need to understand is there any structure or not, DBSCAN and also MinShift could be quite useful. DBSCAN also, like fuzzy clustering, allows you to have some points which are not put in any cluster. Sometimes it's useful, sometimes not. MinShift does not distinguish circles or moons, but at least realize that no structure has no structure, and does something strange with the last example. And model-based clustering is very good with three classic clusters and anisotropic clusters, and even with the very last example of two overlapping clusters, but not good at all with all other examples, especially bad with situation where there is no structure. So it's a bit dangerous when your data has no structure. So lots of information about different methods of clustering analysis. Again, if you have all these packages installed, first three columns are basic R, next two columns is a cluster package with included in R. Spectral might also doesn't require any installation, but four last columns will require you to install some packages. When you have all this installed, you can then see what is going on and even construct new command which give you this comparison. So now, like internal commands of R, compare it in the same way, much faster. So what are they? So they are actually word methods of two different kinds: UPGMA, single linkage, complete, WPGMA, WPGMC, and UPGMC. So all methods are internal to R. All methods are used in hclust commands. So you can simply run hclust help to see description of this method. So they are described here. What are they? Okay, and you see how different are they. So they are able to do some interesting output. For example, word, famous method which many people use in biology, is possible to distinguish the last example quite well when again one cluster is kind of rough, dispersed, and other overlapping cluster is dense. So that's interesting situation, quite biological I would say, and this is method which allows to work with it. It also works quite well with 3 anisotropic clusters and work with 3 classical clusters. However, it is unable to understand either moons or circles and find some structure in case when structure does not exist. What is very interesting, that single method is able to distinguish moons and circles. It even able to understand that no structure example is no structure. There are some dots of different colors, but only because I forcedly tell this method, give me 3 clusters. In that case, of course, it will give you something, but this is a minority. You can see that these dots are kind of very small amount of, and they definitely show you that example has no structure. However, it is not very good working with the very last example. It does not understand these 2 clusters, like green and blue, are overlapping. So lots of interesting things to meditate on in that simple example, which only involves the internal R methods from hclust command. So you're welcome to experiment as much as possible with that artificial data and see what is going on. The actual command, so command which is GeneHCL data, allow you to make much more diversity of this artificial data if you modify some numbers of centers. For example, you might need like 4 clusters if you like, number of dimensions, amount of noise, and many other things. You can see some different types of data, and if you like, apply these methods to that data. So this is how you can approach the understanding of various clusterization methods with the command gene.cl.data from Shipunov package. So this is it for today. Thank you very much.